Alrighty, guys. Good afternoon, guys. Good evening. Thank you for joining on this live. This is Uncle Sam online tutorial, and this is what I basically do. Like I always say, I come live on YouTube every Monday by 4 p.m. I'm sorry I spent a couple of time before I came on live. It's 4:20 p.m. West African time, so I apologize for that. So, but for now, we're going to get into what we have for today. So, thank you for joining. We are going to be examining indices involving equations, which we examined last week, and today we're going to step it a little bit up by discussing about simultaneous equation. Last week we talked about the linear equation aspect of indices, and it was quite interesting. So for this particular week, we're going to be discussing about the simultaneous equation. So thank you guys for joining. All right. Now, indices involving equation is quite an interesting one. And last week I spent time to talk about the concept of an equation, to give a brief intro about the whole concept of equation. And I gave two very important points about what an equation must have, a must have for every form of equation. First, I said that every equation must have an equality sign that separates the two parts, what is on the left hand side and what is on the right hand side. And another point that I also made mention of about an equation is that it must have a variable. Every equation must have a variable. And variable in this case simply means what you are looking for. And so every equation must have either an equation, it's not negotiable, it's not either, it's not negotiable, it must have an equality sign and it must have a variable. These are the two things that every particular equation must possess. So we're going to go on into what we have for today. Before we consider simultaneous equation, I just want to first of all brushing us up on what we did the previous week. I think on Friday, yes, we started discussing about indices involving equation on Wednesday and also discussed about it on Friday. Now to wrap it up, I'm going to bring at least two equations for us to consider first, and then we'll go into the next aspect. So the first equation I'm going to bring on for us to examine together is this particular equation. If you have, let me write it here, 27 raised to the power of 2x equal to 1 over 9, open bracket, 3 raised to the power of x minus 1. And we're asked to solve for x. So we should find the value of x in this particular expression. Remember, everything that governs indices comes from the laws of indices, and I listed about 7 of them. Please, you can go on to the previous live that I've done. You will see all of them is public, so you can access it and have a fresh start to where we started from, so that you'll be able to pick up from there. And also for those joining, thank you so much for joining. Please consider subscribing to my YouTube channel. I go live every Monday, Wednesday, and Friday for now, and it's at 4 p.m. WAT time, West African time. So please consider subscribing to my YouTube channel and also be updated whenever I go live. So this is what we're going to be considering. We're asked to solve for x in this particular expression, and like I said, the laws of indices are what governs whatever thing you're solving for. Indices, provided the whole concept of indices stems from the fact that you must have a base and must have a power. And indices comes from the word index. An index is simply power. And there cannot be a power without a base. There must be a base that will hold on to the power. It's more like a giant that is now, the power is now hanging on top of the giant. Example is if you have x raised to the power of a. The x here is serving as a base, and a here is serving as the power. So there must be a base so that the power will now come out and show itself. So that's the basic idea. So the next thing I'm going to do here is to, first of all, from the laws of indices, try to see what can we simplify. Remember, math has numerous approach of solving. So whatever I'm doing here, we are not limited to that. This is just like the method that have so become usual to me, and it becomes very, very easier for me to assimilate. And like every mathematical problem, I like to approach it from a mindset of curiosity. What can I do here? What can I simplify? Because behind every complex stuff that you see out there lies step-by-step things. You know, if you look at it critically, you see that, oh, you can actually do something, and by doing something, you are seeing the picture. It's becoming clearer and clearer and clearer. And that's the way I like to approach questions that I solve under indices. So let's get to it. Well, if I look at this particular question, 27 raised to the power of 2x equal to 1 over 9, open bracket, 3 raised to the power of x minus 1. One thing you notice here is this is an equation, because the two things that I mentioned earlier in this slide that must be available before something becomes an equation is there must be an equality sign, and secondly, there must be a variable, and the variable happens to be what you are looking for. So what are we going to do here? Well, I know that 27 is same thing as 3 times 3 times 3, which is same thing as 3 raised to the power of 3. So I could, find a way to reduce 27. It's not really much, it's not adding anything much to what I'm solving here, but it's a simple step to begin with. So I can replace 27 to now be 3 raised to the power of 3, then close up a bracket, because this 27 already has a power, which is 2x. So I'll now put the power outward here. So I've not really done much, I just simplified it so that we can get started with that. And then secondly, I can do something to this 9. Remember the laws of indices that state that if I have, let's say, x raised to the power of minus a, it is the same thing as 1 over x raised to the power of a. Now, what I'm simply trying to say is, anytime you see 1 over, that is the reciprocal of any number, it can also be represented as in this form. That means I bring the expression here up, and then the power of the negative, I now attach it to the expression. So that's exactly what I'm going to do to this 9. And then, like I said, it's not really much, but it's something that we can start off with, in our process of trying to simplify this and solve for the variable x. So what I'm simply going to do here is, I'm going to bring this up, so this becomes equal to 9 raised to the power of negative 1. So I've replaced 1 over 9 here to become 9 raised to the power of negative 1. Then open my bracket and say write what I have here, which is 3 raised to the power of x minus 1. We've not really done much, but this is the right step. It's a good step in the right direction. So we're actually getting there. So the next one I'm going to do here is to simplify this from one of the laws of indices, which say that if you have two powers, one inside and one outside, they go on to multiply themselves. So this is going to be 3 raised to the power of 3 multiplied to 2x. That's what we're going to have here. And then for this 9, I know that I can also simplify 9 to become 3 times 3, which is same as 3 squared. So I will place 9 here to now become 3 squared, then everything raised to the power of negative 1. And then, open bracket, you still have your 3 raised to the power of x minus 1. So you see, we're not there yet, but we are gradually making progress. We are gradually simplifying it, because math, you get a complex subject or complex question, you then start simplifying it, breaking it down into what you already know. And this requires step by step and also curiosity, doing something that is, according to the rule of math. So what I'm going to have here is what I did for this side by multiplying the power inside with the power outside. I'll equally do that here. So this becomes 3 raised to the power of 3 times 2x is going to give me 6x equals to, then this power here, which is 2, multiply negative 1, and this will give me 3 to the power of negative 2. And then, open bracket, 3 to the power of x minus 1. Now, the next thing I'm going to do here to further simplify this particular expression is this. Since this particular expression here, which is serving as a coefficient, is multiplying everything inside here, and by extension, that means that there's an invisible multiplication sign here. I can now employ the basic law, the fundamental and the first law of indices, which is the multiplication law, which means that if we have two bases that are the same, and we have powers, we can simply pick one of the bases and then add up the power. That's what we're going to do here. So what I'm going to do here is simply, this will still be, or stay the way it is, 3 raised to the power of 6x equals to, since this base and this base is the same, so you now say that the whole point of simplifying 27 first to become 3 raised to the power of 3, and also simplifying 9 to become 3 raised to the power of 2, is to bring the whole idea of indices into play here, which is having a base and a power. And in this particular case, to simplify them to all have the same base, since it is very, you can do it here, since you can do it here, then it's very okay for us to carry on with it. So what we simply do here is just to multiply these two together. And multiplication of indices simply means pick one of the base and add up the power. So here, you need to be very careful. So this becomes, pick one of the base here, which is 3, and then add up their power. The first power here is -2 for this. And then this multiplication sign here becomes an addition, plus this particular 3 here, which is the base, has its own power of x minus 1. This is what you have at this point. And so what do you do next? You use this positive sign here and multiply or clear off what is inside the bracket. Or you can use what? A negative. If it's a negative here, the reason I put a bracket is to tell you that there has to, the sign here is one that is trying to expand the bracket. So at this point, what I'm going to have is that 3 raised to the power, let me write it here, 3 raised to the power of 6x equals to 3 raised to the power of -2, then plus x minus 1. Because what happened here is simply the positive here multiply the x, it gives us positive x. Positive multiply negative here gives us negative, and then you attach the 1. So we cannot go ahead and simplify here. So this gives us that 3 raised to the power of 6x equals to -2 will come and affect -1. So -2, -1 will give us -3. So it's something as saying 3 raised to the power of x minus 3. This is what you have after you've simplified it. And so what is the next step to do here? The next step we can do here is, according to the laws of indices, if the bases are the same, then it simply means that the powers must be the same. So since bases are the same, I can write it out. Bases are the same, then powers must be the same. So if that is the case, we leave the base and start working on the power now. That's what we're going to do. So simply put, we're just going to have 6x, which is all for this left hand side, equals to x minus what? 3. This is what I'm going to have. And I'm going to have to clean this side to continue so that we can finish up here. So what I'm going to do is clean up here, my bad, so that we can finish up. And to finish up, we actually do something that is very interesting. How? We collect like terms. By collecting like terms, I thought in the previous slide that I went on that there are 2 ways of doing this. It's either this x here is what I want to move over to this left hand side, so that the variables will just stay one place and then the numbers will stay one place. That's what I want to do. And there are 2 ways you can do that. How do you do that? Since this x here is a positive x, you can subtract x from both sides. Or the short way that we normally do this is we move positive x over to this left hand side. Both of them will see you the same output. So what I'll simply do is say that subtract x from both sides. By subtracting x from both sides, it's going to be, on the left hand side, you have 6x minus x equals to x plus 3 minus x. So that's what we did, subtracting x from both sides, which is also the same thing as moving positive x over to this left hand side, and it becomes negative. So it's still the same process. So 6x minus x will give us 5x equals to x plus 3 minus x. C minus x will go on and clear out positive x. So that what we have in the end is just that your 5x equals to 3. And then you divide both sides. Divide both sides by the coefficient of x. So if you divide both sides by the coefficient of x, which is 5, that your x equals to 3 over 5. So this is what you have for this given expression. Remember, we're just trying to make sure that we understand the whole idea of indices involving equation. And for this particular question, we examine linear equation. Yes, because it led us to a linear equation where you have 6x equals to x plus 3. We're just looking for one particular value that will satisfy this given expression. So we're done with this. So the next one I'm going to do now is to solve one more question, and then we'll move on to simultaneous equation involving indices. I hope this is clear. Thank you so much for joining, guys. Thank you. Appreciate you all here. Thank you. Thank you. So I'm going to clean it up. I'm going to wait for maybe 2 seconds or 3, and then I'll clean it up. I'm going to count 1 to 3. 1, 2, and 3. So I'm going to clean this up, and then we'll examine another question before we now move on to simultaneous equation. So stay with me. If you're just joining, trust me, you're going to understand it, because the whole idea is to transition you beyond knowledge to gain understanding, and I like breaking down stuff. That is why I'm here, and I'm going to try to help you to understand it by breaking it down in a way that is going to be very easy for you to assimilate. So look at this other expression that we're asked to find. So if 5 raised to the power of 2x plus 1 plus 5 raised to the power of 2x equals to 150. Find x. This is just the final question I will solve for equation for indices involving equation. Under this part, we are still considering just linear equation. I just want to wrap up on it and then go into simultaneous equation, which is the main focus for our class today. So look at this given expression. 5 raised to the power of 2x plus 1 plus 5 raised to the power of 2x equals 150. Now, one thing that you notice is, we know from the basic law of indices that if I have a raised to the power of n multiplied to a raised to the power of m, well, we can go ahead and just do, since the bases are the same, and then there's a multiplication sign separating them, according to the first law of indices, which is the multiplication law, you just add up their power. This becomes, pick one of the base a and then add up the power. But there is no provision in the law on what you're supposed to do when we have a base having power and then it is being separated by a positive sign. There's no law that tells us what to do here. So what are we going to rely on to do here? Well, here, because in math, if I go forward, I can also go backward. So it's more like I'm reverse engineering some process here. So stay with me. This is what I'm going to do. There are 2 ways of solving this particular equation, but I'm going to reverse engineer this particular equation. What do I mean? If I have 5 raised to the power of 2x plus 1, just like we'll have a raised to the power of n multiplied to a raised to the power of m equals to a raised to the power of m plus n. So if this is the same, if this is equal to this, that means I can choose to represent this thing this way, or choose to represent this one this particular way. So what I'm going to do is I'm going to reverse engineer this particular part, this particular power here, and there's a reason for that. If I reverse engineer it, it's going to be based on the laws of indices. So we're not going away from that law, but we'll still maintain the law, but we're reverse engineering. So this is the same thing as 5 raised to the power of 2x multiplied to 5 raised to the power of 1, and then plus your 5 raised to the power of 2x equals to 150. This is what we have at this point. So this is what we have. Now, if we get to this point now, you know that this thing, you see the same thing as this. We've not done anything wrong. This and this are still the same thing. So what are we going to do at this point? Well, we can actually go by this. Look at what we're going to do. Since we have this at this point in time, we can just simply say that this is the same thing as 5, which is the same thing as 5 raised to the power of 1, multiplied to 5 raised to the power of 2x, then plus 5 raised to the power of 2x equals to 150. It's still the same thing. This and this, they are still the same thing. We've not done anything strange at this point. Nothing strange. So what am I going to do at this point here? Now, since these 2 expressions are separated by a positive sign, whether positive or negative, there's something we can do. What can we do? We can choose to factorize. In factorizing, we are trying to find what is common. And since this part and this part are demarcated or separated by a positive sign, we factorize by finding what is common. And if you look at this now, you can agree with me that what is common between this side and this side is 5 raised to the power of 2x. So if that is the case now, what I'm going to do is I will bring 5 raised to the power of x, 5 raised to the power of 2x outside. So this becomes 5 raised to the power of 2x as something that I factored because it's what is common between this side and this side. So I'll now put a bracket inside. So if I put a bracket inside, I'll now use this that is common between these two parts to divide each of the expression. That is a simple way of factorization. Let me repeat it again. We have at this point 5 dot here means multiply to 5 raised to the power of 2x. It's just another way of representing what we have here because 5 raised to the power of 1 is same thing as 5. So if we get to this point now, what I simply want to do is, because there's nothing else I can do at this point based on what we have currently, because this is not a multiplication sign, it's an addition sign, I choose to factorize. And what do I mean by factorizing? We are factorizing when we find what is common between two expressions, either separated by a positive sign or a negative sign. We find what is common. And in this case, what is common between these two parts is what? 5 raised to the power of 2x. So I bring that 5 raised to the power of 2x outside. Open up a bracket. Then the next phase is use that thing that is common and divide each of the side, each of the given expression here. So if 5 raised to the power of 2x goes on to divide 5 into 5 raised to the power of 2x, it will simply cancel out. It will cancel out 5 raised to the power of 2x. And what is remaining is just what? 5. So 5 will remain. So that if I go ahead and expand back 5 raised to the power of 2x multiplied to 5, it will voila, it will give me back this. So there's nothing much that we're doing here. We're just simply factorizing. And then I'll add my plus sign here and do the same thing for this part. So if 5 raised to the power of 2x divides 5 raised to the power of 2x, anything divided by itself is going to give me 1. So I'm going to have 1 here. Voila. So that if I do the same thing, if I reverse the process, use 5 raised to 2x, multiply 5, I get back this. Use 5 raised to the power of 2x, multiply 1, I get back this. So this is just the whole idea of factorization. So once we've done that, we have that this is equal to what? 150. So this can also be arranged as 5 raised to the power of 2x into what? 6 equals to 150. Now that we have done this, what can we do here? Well, I can choose to divide both sides by 6. Divide both sides by 6. That's another thing that I can do here. If I choose to divide both sides here by 6, what's going to happen? 6 will clear out 6 here. And 6 divide 150. 6 divide itself 1. 6 divide 115 is going to give us 2 remainder 3. And 6 divide 30 will give us what? 25. So we see that it's now simplified in a way that we can apply some basic laws of indices and simplify further. So at this point, what we have remaining on this left-hand side is simply 5 raised to the power of 2x equals to what we now have remaining for this right-hand side after we have simplified and divided both sides by the coefficient of the 5 raised to the power of 2x here. We have just that 25 is remaining. So it's looking simplified now. From here, this is what we have done. And in between here and here, we did a bit of simplification and factorization. This is to tell you that some of the basic things that we learn in maths are applicable even in higher or complex mathematics. We're still doing the same thing over and over again. So the next phase now is it where I can reduce 25 to have a base of 5? Yes, I know that 5 times 5 equals to 25, and that is equals to 5 squared. So I can replace this 25 to be 5 squared, which is simple enough. 5 raised to the power of 2x equals to 5 squared, because 5 squared is same as 25. And we apply the same process as with the previous question, where if you have the same base, equate the power. Since bases are the same, equate the powers. So since the bases are the same, we neglect it and now equate their powers. How do we do that? So it becomes that the power of the left hand side, which is 2x, equals to the power of the right hand side, which is same thing as well, 2. And then what we do at this point, we divide both sides by the coefficient of x. That means we divide here by the coefficient of x divided by the coefficient of x. And we see similar with that, this is what we're going to have. We're going to have at this point that our 2x will be divided by 2, and here you have divided by 2. Meaning that we have divided both sides by the coefficient, the number beside x. So 2 cancel 2. 2 divided by 2 is going to give us 1. So what is remaining on this left hand side is x. And if you divide it here, it's going to give you 1. So the value of the variable that satisfies the original expression, which is that 5 raised to the power of 2x plus 1 plus 5 raised to the power of 2x equals to 150, is what? when x equals to 1. And I can go on to check. I think that's the last thing that I will do. I'll go on to check if this particular expression is correct. That is to say, if the answer that we got for this given question is actually right. How do you do that? Anywhere you see x, substitute it with 1 here. That's what you do. So this becomes 5 raised to the power of 2 open bracket 1. We have just replaced x here to be 1 because that's what we got when we solved. And then you have plus 1, then plus 5 raised to the power of 2 open bracket what? 1. Is it equals to 150? We are about to find out. So this is the same thing as 2 times 1 is 2 plus 1 plus 2. 2 times 1 is 2 equals to 150. Is it? 5 raised to the power, this is gone 5 raised to the power of 3 plus 5 raised to the power of 2 equals to 150. Is it? 5 raised to the power of 3 is the same thing as 125. Then 5 raised to the power of 2 is the same thing as 25. Is it equals to 150? I think we are approaching that. So if you add this together, it's going to give you 150 equals to 150. So the value of this x actually satisfies the given expression. Yes. So the unknown that we found here is actually the perfect for this given expression. So that is basically it for indices involving equation. Under this case, linear equation. So the next thing we're going to do now is to enter the concept of the simultaneous equation. It's quite easy. I'm going to explain it like I always do. So let's get into it. Thank you so much, dear. Thank you for tapping. Thank you. I really appreciate it. Thank you. So I'm going to clean this in 3 seconds. So I'll give you time to, maybe if you want to take a screenshot, take a screenshot, and then I'm going to clean in 3 seconds. I'm going to clean it in 1, 2, and 3. Thank you. Let's get into the real deal, which is simultaneous equation. All right. Simultaneous equation. So the major focus of our life now, which is not going to take so much time, is us exploring indices involving equation. And the equation we are seeking to explore under indices now is simultaneous equation. What is the basic idea behind simultaneous equation? It's just 2 equations that are solved at the same time. If something is happening, or if 2 or 3 things are happening simultaneously, it means they are occurring at the same time. And it's something of this form. If you have, let's say, a plus b equals to 10, and then 2a plus 2b equals to 12. These are 2 equations. And these 2 equations, they are linear equations. But if I have just a plus b equals to 10, I cannot get the variable for a and b. Because if this were just a plus, let's say, 5, I can be able to subtract 5 from both sides. And if I subtract 5 from both sides, I have that my a will now be equals to 10 minus 5 is 5. And if I plug a equals to 5 back to this given expression, it's going to give me 5 plus 5, and that will be equals to 10. That means that it is satisfied. But because now here is not 5, but here is b, that is why the concept of the simultaneous equation comes into play. Because for simultaneous equation, we cannot solve the individual equation separately. We need to solve both of them together, provided that both of them have the same variable. So you see, the whole idea is the 2 equations being solved at the same time must have the same variable. What I mean by that, you cannot solve, if I have this expression, I have 3b plus c equals to 12. I can't go ahead to solve this simultaneously, because here I'm having a and b as a variable, and here I'm having b and c. There's been a slight change in the variable. So because of that, I cannot use it. So the whole idea of solving simultaneous equation is that the 2 variables that you're looking for must be the same. So now involving indices, now remember, indices has to do with a base. I don't want you to forget it. The word indices comes from the word index, and index has to do with pairs. And there will never be a pair without a base. Anywhere you see power, check very, very well. You must see a base. You cannot see a power without a base. So we'll use an example here to discuss this so that it will stick well in our head. So look at the example. This example will help you to, be able to look at the question and know how it comes. how it comes, I've already explained to you that simultaneous equation talks about two variables must be involved. Two variables. The previous example that we saw before now, both for the first and the second that we saw, had just one variable. We are just asked to find x. But for simultaneous aspect, nobody is going to tell you that it is spelled out simultaneous. You need to look at it. How many variables is this given expression having? And that's one of the clues that gives you an insight that this is actually going to be solved using simultaneous approach. So let's get to it then. An example, if 5 raised to the power of x plus 2y, that's the question, equals to 5, and the 4 raised to the power of x plus 3y equals to 16, look at the question, find 3 raised to the power of x plus y. So you see the question that we're asked here, we're asked to find the value of 3 raised to the power of x plus y. Now, why is this question this way? Well, there are a couple of reasons why it's this way, because since we are talking about indices which has to do with a base and a power, it's very right for this equation to come this way. It's what you expect, because it's not spelled out, it's not the topic simultaneous equation that we are discussing. We're just implementing knowledge of simultaneous equation in solving indices. That is what we are doing. So let's get into it. So what can you see from this given word expression? For any given simultaneous equation, you have your equation 1 and equation 2. And normally your equation 1 is the first equation given, and the second one is your equation 2. So just to be clear. And there are two basic methods of solving simultaneous equation. Although there are other advanced methods, we have the matrix, using matrix method to solve simultaneous equation. But the two most basic way of solving simultaneous equation is either the elimination method or the substitution method. And depending on the way the equation comes, that is where you tend to pick which one you want. Although any of them can work, but I like using the elimination. The substitution is still cool though. So let's get into it. So the first expression is 5 raised to the power of x plus 2y equals to 5. This is our equation 1. Well, what can we do to this our equation 1? Because I feel like we can actually simplify it. Because 5 is same thing as 5 raised to the power of 1. Yes. We can express this 5 as 5 raised to the power of 1. So if that is the case now, since the bases are equal, we equate their power. So the bases cancel out, and then it becomes x plus 2y equals to 1. This now becomes our main equation 1 that we'll be using to solve the simultaneous equation. So what I basically did, I've not really done more. I just kind of simplified the whole expression, because I see the base being equal. I made the power of the 5 here to become visible because it's 1. And then I now, since the bases are equal, you equate their power. That's what I simply did here. So this becomes my equation 1. And then I do the same thing for this left hand, this second equation, which is 4 raised to the power of x plus 3y equals to 16. Well, what can we do? Is there a way we can simplify this base so that 16 can have the same base as what? 4. Well, it turns out that 4 times 4, which is the same thing as 4 squared, equals to 16. So I can replace this 16 to now be 4 raised to the power of x plus 3y equals to 4 squared. And then since the bases are equal, we equate their power, just like we did here. So this becomes x plus 3y equals to 2. This is now my equation 2. So to write this better, this becomes that the first equation, which is x plus 2y equals to 1, this is my equation 1, and x plus 3y equals to 2, this becomes my equation 2. So this is now looking plain as what? A simultaneous equation. So what do you think I'm going to do here? Apply the method of solving simultaneous equation and then get the answer. That's basically what I'm going to do here. So how do I do that? Well, I told you there are two methods of solving simultaneous equation. One is your elimination method and one is your substitution method. Short form, the elimination method is just cancelling out. When you see that a variable have the same coefficient, for example here, x and x here, both of them have the same coefficient, which is 1, although it's invisible. You can use what? Either plus or minus sign to eliminate the variable, one variable completely, and then the other one stays. That's what they mean by what? Elimination method. The substitution method is when you take either of the equation, make one variable subject of the formula. If I take, let's say I take equation 1, I make x to become subject of the formula by moving 2y over to this left, the right hand side, which is something as subtracting 2y from both sides. So if this x now becomes alone, it becomes my equation 3. I now take that value of x, substitute it into equation 2, so that when I do that, there will no more be x in equation 2, there will now be y. Simply, I will simplify, find the value of the y there, and when I get that, I substitute back. It's a whole lot of things, but it's actually quite easy. But for this particular question, I'm going to be sticking with elimination method because it's quite easier. Maybe after solving with this elimination method, I'll go ahead and solve with substitution method so that you see it clearly. So what am I going to do here? Since I have a variable x here and the coefficients are the same, they have the same coefficient, which is 1, 1. I'm going to eliminate. And if I want to eliminate this whole variable, I need to think whether I'm going to be using a plus sign or a minus sign. If I use a plus sign, it's not going to eliminate, so it's obviously going to be a minus sign. So if I have x minus x, it's cancelled, it's 0. We don't need it again. So it has what? Cleared out. And then if you come over here, 2y minus 3y will give us minus 1 equals to 1 minus 2 will give us what? Minus 1. So once we've gotten to this extent, since minus is common to both sides, they can cancel out. Yes, because there's an equality sign separating them. Minus is common, it clears out. So our y is equals to what? 1. We have found y already. This is quite easier because the expression came in such a way that it was quite easier for us to go about simplifying using this elimination method. So once we've gotten to this extent now, the next thing that we're going to do is we're going to put, since we have found y now, we're going to put the of y equals to 1 in any equation of your choice, whether equation 1 or equation 2. So put y equals to 1. I want to put it in equation 1. So anywhere I see y now in equation 1, I'll replace it with 1. So going forward, this becomes x plus 2 open bracket 1 equals to 1. That's how to use the elimination method, okay? The main thing is once you found one variable, you take the value of that variable and substitute in either of the two equations given. So at this point, you just have that x plus 2 times 1 will give us 2 equals to 1. We are looking for x, not x plus 2. So I'm going to subtract 2 from both sides. So what I'm going to do here is, I'll clean this up. I want to leave the question purposefully because I want to use substitution method to solve it to show you how that is done. And that is where we're going to be ending today's slide. So at this point now, what I'm going to have is that since x plus 2 equals to 1, I'm looking for x, not x plus 2. So subtract 2 from both sides. That's what I want to do. So this becomes x plus 2 minus 2 equals to 1 minus 2. That's what you mean by subtracting 2 from both sides. So this goes on to clear this, and I have that your x is equals to what? 1 minus 2 is going to give us minus 1. So therefore your x equals to minus 1, and your y, you already found it to be equals to 1. But that is not the end, because the question did not ask us to find x and y. The question asked us to find the equivalent of 3 raised to the power of x plus 1. So this becomes 3 raised to the power of x plus y will now become 3 raised to the power of what? X is minus 1, then plus y is what? 1. This is same thing as what? Minus 1 plus 1 is going to give us 0. So this is same thing as what? 3 raised to the power of 0. And anything at all, any value at all raised to the power of 0 equals to 1. So this is equal to 1. So that's what you have. So we've actually simplified this whole expression to give us what? 1. This is how you solve using simultaneous method. The main thing is to know how to use the different methods of solving simultaneous equation, which the basic ones include your substitution method and your elimination method. There is still the matrix method of solving, which is quite easy, but we're not going to make it more complex at this point. So I'm going to use one last thing I'm going to do before we call it a day, and then on Wednesday I'm going to be treating indices involving equation, and under that section we're going to be having quadratic equation, how to solve indices equation that has quadratic or low quadratic in low quadratic. So that's what I'm going to be doing there. So I'm going to simplify this expression again using substitution method. That's what I'm going to be doing. So this is using elimination method. Is using elimination method. So take a screenshot, guys. Take a screenshot. If you can take a screenshot. I'm going to clean this in 3, 2, and 1. I'm going to leave the original equation so that we'll kick off from there. Alright. So let me write the original equation, which is x plus 2y equals to 1, and the x plus 3y equals to 1, equals to 2. This is my equation 1 and this is my equation 2. So let me clean this up now. So now that I've done this, now what I'm going to simply do is this. Remember this one is using substitution method. Let me just show you how this is done. Substitution method. So how do you use substitution method to solve this type of equation? It's quite easy. So what you do is you pick any of the equation of your choice and make one variable subject of the formula. So from equation 1, I want to use equation 1. X plus 2y equals to 1. And then if I subtract 2y from both sides, it becomes x plus 2y minus 2y equals 1 minus 2y. So that this clears out this, so that I have that x plus x is now alone on the left hand side equals 1 minus 2y. This now becomes my equation 3. Get it straight. The first step is make one of the variable, not the variable and its coefficient. Not the variable and its coefficient. If there's a coefficient, you still have to divide. If after making this x object there was still a coefficient here, I still have to divide both sides by that coefficient. Your duty is to make the variable to be alone. Let the coefficient be, let the only coefficient that is beside this variable be 1, and let that one be the one that is the invisible one, which is normal for any given expression. So what we simply do here is, at this point that we've gotten that our x now, which is one of the variable, is now alone, equals 1 minus 2y. It becomes an equation 3. Then we proceed to say, put x equals 1 minus 2y in equation 2. So what this simply means is, remember, you pick one of the equations of your choice. Then you make one of the variables subject of the formula. And then once you've done that, use the endpoint of that making subject of the formula and substitute into the second equation. So anytime I see x in second equation, I'm going to replace it with 1 minus 2y. So it becomes, this is our equation 2 is x plus 3y equals to 2. It becomes 1 minus 2y, this is for x, then plus 3y equals to 2. I just substituted x to be what? 1 minus 2y, because that is what it simply means. That is the whole idea of the substitution method. So once I've gotten to this point, open up the bracket, becomes 1 minus 2y plus 3y equals to 2, sorry. And so when you get to this point, minus 2y plus 3y will give you plus y. So this is saying 1 plus y equals to 2. And so when you get to this point, what you simply do is you subtract 1 from both sides. The reason you are subtracting 1 from both sides is so that this y will be alone. So if you subtract 1 from both sides, it becomes 1 plus y minus 1 equals to 2 minus 1. So that this 1 will cancel this negative 1. So that y will now be equals to 2 minus 1, 1. You see, we got the same y equals to 1, which we got when we use elimination method. So there's nothing really much. You are still going to get the same value for both cases. So I want to clean up here and then proceed to find my x. So since I found y to be what? Equals to 1. The next thing to do is put y equals to 1 in equation. I want to put it straight to equation 3. Well, you can put it to equation 1, you can put it to equation 2. But the reason why I chose equation 3 is because x is already subject of the formula. So I don't need to do any extra math. Just put x here, y here to be equals to 1 and then simplify only the right hand side. So putting that, I'm going to have that x will now be equals to 1 minus 2 open bracket 1. I just replace my y here to become 1. So it becomes x equals to 1 minus 2 times 1 will give you 2. And so that means that my x is equals to what? Minus 1, because 1 minus 2 will give us what? Minus 1. So we see that we still got the same value for x and y as we got using the elimination method. And I hope that you understood everything that we actually did in this particular video. If there's any part that you were lost, please leave it in the comment section and I'll attend to you. Please. Thank you so much. We've come to the end of this live section. I hope that you enjoyed this live section. Remember, we treated simultaneous equation under indices, and equally I also stated that I'll be going live Mondays, Wednesdays, and Fridays. So by 4 p.m. West African time. So if you enjoy this section, do well to join me 4 p.m. West African time. it's going to be interesting just like it was today. So thank you for joining, and bye bye.